trigonometry, and applying the sine and cosine law. The sine law is the sine ratio of angle A over its corresponding sides, this side opposite angle A, which is equal to the sine of angle B over its opposite side, side B, which is equal to the sine of angle C over the opposite side, C. It can be used when we have a complete pairing. We need to have a complete ratio here in order to solve something. So if we know sine A, or angle A, sorry, and side A, and any other piece of information, we can solve that triangle. So the key is we need to have the angle and the side opposite it, as well as one other side in order to use it. Or if we had two angles and any side, we could use it, because even though we don't have sine C to make that complete pair if we don't have angle A, we can find angle C by using the angle sum of a triangle theorem. The cosine law is A squared is B squared plus C squared minus 2BC cos A. So if I know two sides, and if I think about the triangle ABC that's created using these side lengths and angles, if I look at where A, B, and C are located, if I compare side C and side B, angle A is tucked neatly in between them. So when I know two sides and the contained angle, I can use the cosine law. The key here is this side length must be the one opposite the angle we're using to solve. Also, if I know all three sides, A, B, and C, the only unknown left to solve for is angle A, so I can use cosine law in that scenario. Example 1. Remember, we're going to read the question, highlight the key information, and underline what we're looking for. A field is in the shape of a triangle ABC. A surveyor determines that the length of side A is 620 meters. Using a theodolite, the surveyor determines that angle A is 56.8 degrees and angle B is 60.4 degrees. Determine the perimeter of the field correct to the nearest meter. Now it says at the bottom, FYI, a theodolite is a tool used in road building, tunnel alignment, and other civil engineering work that measures angle. I Googled it because I didn't know what it was. A field, so it doesn't really matter what it is. It's just telling us they're using a tool to measure angles. Let's go back, highlight the information so we actually have an idea of what it's told us in the picture or in the question. Fields in the shape of a triangle. So this is actually a field, ABC, and it's drawn here below. The length of side A is 620 meters. I don't care about what they used to get it. Angle A is 56.8, angle B is 60.4. Determine the perimeter of the field to the nearest meter. Let's try that one more time. The length of side A is 620 meters. That's a useful piece of information that I can put on my diagram if my pen actually was going to work for me right now, which apparently it seems to be being glitchy. So we'll try that another way. 620 meters. Because of course the picture's worth 1,000 words and it's going to make life a lot easier for us to solve. Okay. The angle A is 56.8 degrees, so we're going to add that in. Sorry guys, this is not very neat. The Moby decided it doesn't want to work for me again. And angle B is 60.4. So we've put all our useful pieces of information on our diagram. And we should have our degree symbol here on our angles. And we should have this labeled as meters. Determine the perimeter of the field to the nearest meter. So we're actually looking for the perimeter and we're looking to find it to the nearest meter. Fortunately, the next slide is a little cleaner and we're going to clean that up a bit so you guys can actually see things. One more thing before I move on, because it's written on the next slide and I want to talk about it before I actually show it to you. Is there any other information we can add to this? And the last piece of information we can add here is in fact the third angle, because we know the angle sum of a triangle theorem, so we know that angle A plus angle B plus angle C is 180 degrees. So if I add that piece of information into my diagram, it doesn't take me long, but it gives me one more piece to visualize how to solve the other information. So our diagram ends up looking like this. Now, I'm looking for the perimeter, and perimeter means distance around. So the next thing I need to find is the length of the other two sides. Go to another slide. So we know, if I look at this, if I tried sine law, because I do have an angle and its opposite side, a complete pair, and I do have two other angles. So that tells me once I see that ratio, and what I like to do is often take my pen. Let's see if the mobile be cooperative again, and it does not look like it wants to be cooperative. So we'll move on. If I take my pen, remember what I said in class, if I can see this complete ratio, that's a pretty good indicator that the sine law is going to work. So I can write 620 over the sine of 56.8 equals side C over the sine of 62.8 equals B over the sine of 60.4 degrees. And that's what you see right there. So what I can do is I can set this complete ratio up to either one, set it equivalent to either one of the other two ratios. So I can come up with two equations to solve. And now we use our strategies for solving equations. What I can do here is I can multiply both sides by both denominators, and I get B sine 56.8 is 620 sine of 60.4 degrees. Now I need to get side B by itself, so obviously I need to divide by the sine of 56.8 degrees on both sides, of course, because I'm keeping my equation balanced. And then I can use my handy dandy calculator, and I can solve for side B, sorry. Similarly, I can do the same thing to solve for side C. I can multiply both sides by both denominators, so I get C sine 56.8 is 620 sine of 62.8. I need to get side C by itself, so I'm going to divide both sides by the sine of 56.8 degrees. And then I'm going to get out my handy dandy calculator, and I find that side C is approximately 659 meters. The last thing I need to do, what did the question ask me to find? Let's go back. I got all excited. I solved both sides. I solved all the angles. I need the perimeter. So I need to add up side A, which we knew was 620, side B, which is 644, and side C, which is 659. So we just substitute that in, and I've made I have made sure that I stored both those numbers that represent side B and side C in the memory of my calculator, so I can go back and recall them and get an exact answer, or as close to exact as I can. So the perimeter of the field is approximately 1,923 meters. And notice I used the word approximately in my sentence answer because I did round, and that's important. It is a word problem. It requires a sentence answer, and if there's rounding, we put the word approximately in. Much like everywhere we used a rounded number in the question, we put a dot above the equal sign the minute we started using rounded values. Example 2. The points X and Y are located at each end of a small lake. Point Z is on land. The distance from Z to end X is 300 meters and to end Y is 400 meters and angle Z is 47 degrees. Determine the length of the lake correct to the nearest meter. I got nothing out of that. So I'm going to go back through with my highlighter and I'm going to read it again and highlight the information. X and Y are at each end of a small lake. Okay. Z is on land. The distance from Z to X is 300 meters and to end Y is 400 meters. So that would mean from Z to Y, I would think. And angle Z is 47 degrees. And I want the length of the lake correct to the nearest meter. Let's try this one more time, getting some information or underlining units and what we're solving for. The points X and Y are located at each end of a lake. Point Z is on land. The distance from Z to X is 300 meters and to Y is 400. The angle is 47 degrees. Wants the length of the lake to the nearest meter. So the first thing I need to do is draw a diagram. And I've got the idea it's going to be a triangle because X and Y and Z's on land tells me the distance from Z to X is 300. And Z to Y is 400. Couldn't be X to Y because XY is the length of the lake, isn't it? So we actually, even if we weren't sure that it was talking from Z to Y, we would have to assume that because we're solving for the length of the lake, which is side Z. Angle Z is 47 degrees. If I look at that, I have no way of finding any other information about the other angles. Let's run through the things we had for solving triangles. We had angle sum of a triangle theorem. We only know one angle. We can't use it. Pythagorean theorem and the primary trig ratios, they can't be used because there's no right angle. Sine law can't be used. There is no complete pair. But if I wrote it out the cosine law, I would see that I have, let's take a look at the picture here. Z squared is what I'm looking for because that was the length. That's the length of my lake. I know x squared and y squared and angle Z, don't I? X squared, y squared, and I know angle Z. So I can just substitute straight in and use the cosine law. Now my good friend BEDMath takes control here. It tells me, evaluate my exponents first, because obviously there's no work to do in any of the brackets, and then I do division and multiplication in the order they occur. Now, be careful when you get to this point here where you have 250,000, subtract 240,000, cos 47. We have to multiply that 240,000 with the cos of 47 because that's the operation that occurs with them. You cannot do that subtraction first. You must multiply 240 cos 47 first. Make sure you get out your calculator and you test that out. Now we're working with rounded numbers. We should have dots above our equal signs here, and we square root. And it's said to the nearest meter, so we round to 294 meters. And again, therefore the length of the lake is approximately 294 meters. And just a couple quick questions to try. Exercise 7, page 14, number 2 to 5.